Okay, so this lesson is to take you through interval notation, and it is an extra credit lesson for Algebra 2. This needs to be turned in on Focus before Friday for extra credit. So if you're doing this during the third test day for our Radicals test, then you can watch the video, complete the assignment, and submit it into Focus during class. If you are still taking the test, you have until Friday if you would like to take advantage of the extra credit opportunity. So first off, what is interval notation? It's something that I told you guys specifically not to use on this test because it is not something that I've taught you, and I'm really adamant about you not using notation and vocabulary that you aren't sure what it is. But interval notation is another way of stating a particular set of numbers on the number line. It's an alternative to using inequality notation, such as less than or equal to, greater than or greater than and equal to. So it's just another way of saying what those intervals might be. Both notations are accepted and are regularly used in math, and in fact, in certain instances, it's better to use inequality notation. In other instances, interval notation might be the better notation to use. In courses such as pre-calculus or college algebra, you are required to use both as directed by the teacher or professor, and so you want to be conversant and fluid in both types of notation, but one does not have predominance over the other as like a better or more advanced notation. They're just different. So this lesson will cover the basics of interval notation so that you will be better prepared to use it in the future. It is generally not a requirement for Algebra 2. It's the kind of thing that if I can teach it in my standard classes, I will, like taking advantage of an opportunity like this to present the material to you. And it is often covered in an honors class, and then once you get past Algebra 2 is when you get into the realms where it would be something that's required for you to do. So I'm going to start with some examples with a number line, so you can see the visual of what it looks like. And I've actually seen some number line lessons done where they use the interval notation symbols on the number line. I'll show you what I mean in a little bit. But for the first example, we have -4 to 3 inclusive, meaning that's like any number in between -4 and +3, including the -4 and the +3. And you know that they are included because the circle is colored in. So you kind of have to go back to what it means to graph something on a number line. Remember, you always like shade in the solution. So if the circle is shaded in, it means that the -4 and the 3 are included. Now, the way you would express that using interval notation, and I do want to make sure that I change my color up here, we'll change it over to green, is you would do the -4, so you always put the lower number on the left, you put the larger number on the right. And they're separated by a comma. If the number is included, then you use a bracket. And so this would be done with a bracket. And so the interval notation would look something like that. You'd have the bracket and then -4, comma 3, and then another bracket because both the -4 and the 3 are included. Now, if you come over to problem number 2 on the right-hand side, then we have -4 and 3 again, only this time we have open circles there. So that means that the -4 and the 3 are not included. So you could go up to like 2.9, 2.99, 2.999999999, like infinitely close to the 3, but not the 3. And so we want to have a way of indicating that it's a 3, that's like the stopping point, but not including it. Now, in inequality notation, we would do it like this. We would say -4 is less than x is less than 3, and we wouldn't have that like equal to. In interval notation, you're going to mark the -4 and the 3 just like you would for like the closed interval, but you'll use the parentheses instead. So a parenthesis indicates that the endpoint is not included. A bracket indicates that it is. Now, here's what I've seen people do. Well, I'll actually model it on number 3. So we'll come down, we'll look at like number 3 for a little bit. So number 3, like I'm trying to keep it pretty consistent here. So we have the -4 and we have the +3. And like what would it look like if you had the -4 included but the 3 not included? So once again, you always put like the lower number on the left and the higher number on the right. okay, or greater number on the right. So always, it's always lower to greater or least to most, or like it's got to go in the order that it would be on the number line. And so we would do the -4 and the 3, and because the -4 is included, you would use a bracket, and the 3 is not included, you would use a parenthesis. So you kind of have this, it looks a little lopsided, but it is lopsided. So you've got one included and one not included. Now here's what I've seen people do, and I've actually seen this taught with the number line before. So if you've got like your number line, and instead of teaching it with the open and the closed circle, which is how I learned it and how I teach it, I've seen people do it with the brackets and the parenthesis like right on the number line, and they've done it with like elementary school kids. And so the elementary school kid doesn't like know what it is, but somebody who knows interval notation knows that you're kind of prepping the student to be able to recognize the interval notation later. Now that comes at the expense of the concept of the open and the closed dot, which is really important as well. Okay, so the next one, so suppose you have like -4 and it's like everything greater than -4. So if you were doing this with inequality notation, like just for the sake of like, we'll just use an X, okay, but you could use an X or a Y or whatever, you would say that X is greater than or equal to -4. And that's how I wanted you to do it on your test, because I know that you know what the greater than symbol is, and like that should make sense to you. Like, okay, we're dealing with numbers greater than or equal to -4. If you're going to do it in interval notation, remember you need the lower number and you need the higher number, except in this example here, there is no higher number. So what do? Well, this number line here is approaching infinity. So it actually gets into the concept of infinity. And so when you go to put your answer together, you would have your lower number, which is the -4, and then your upper number is actually infinity. Because the -4 is included, you will use a bracket, and then infinity always has a parenthesis around it. Because infinity is not a number that can be included. You can include numbers, but you can't include concepts like infinity. Just can't do it. And so you would put the parenthesis around it. Okay, so you'd have -4 to infinity. Now the next one, number 5, that's similar. This is actually the kind that students will tend to get wrong, especially if they're using interval notation for the range, because of the way we might say this out loud. So for number 5, if you were doing your inequality notation, you would say X is less than -3. And so you have this tendency to like really picture like the -3 and then let your eye drift to the left. So your eye kind of homes in on the -3 and then will kind of slink off to the left there. But remember, when we're doing interval notation, if you come back over here to the right, you always put the lower number first and then the higher number. So you really want to be careful about that. So where does this number line go? Not to infinity, it goes out to there we go. Negative infinity. I like lost a piece of my infinity there. There we go. So it goes from, it goes all the way down to negative infinity. So when you're putting your interval notation together, you actually need the negative infinity on the left, comma, and then the 3 will be on the right. So you don't say like -3 to infinity. Okay, you're like negative infinity to the -3. You always put a parenthesis around the infinity because it's a concept, and then this, because the -3 is not included, then you would use a parenthesis. Now, number 6, this gets into having like 2 intervals, and if you think back to our absolute value inequalities from a million years ago, like the beginning of the school year, we would have like 2 separate inequalities for this, and X could be in one section or the other. So I want you to keep that in mind. This is like an or. So your X value could be like over here, or it could be over here, but it can't be in both places at once because there's just no number that would be in both places at once. So this is actually expressed with 2 intervals, and a union symbol between them. So, and we don't do a whole lot with set theory in Algebra 2 or in math in general. One of my dual enrollment classes, we do a lot with sets in the very first unit, and so they get very good at like union and intersection and like the complement of a set and stuff, because we do a whole unit on it, which is kind of fun. But the symbol for union is or. It means like, okay, this set union with this set is the solution set. Like the two of them together constitute all of the possible answers for x. And then other than that, it's pretty much what we've done before. So that end of the number line goes off to negative infinity. This end of the number line goes off to positive infinity. And so you actually have two intervals. You'll have negative infinity, comma, negative 4. And then you're going to have the other one, which will be 3 to infinity. The negative infinity will have a parenthesis. The negative 4, because it's included, will have a bracket. The 3, because it is not included, will have a parenthesis. And then the infinity always has a parenthesis. And then you would put the union between them. That is the kind of thing that photomath, Wolfram Alpha, what are the like Symbo Math, like whatever, they'll give that to you as a solution set for like an inequality. And I know unless somebody has really stopped and taught you what the notation means, like when students start putting that on their papers, like that they're copying it from somewhere, and you want to be aware, like if you're copying stuff, like, okay, that's not actually something I know what it means. But now you would have like an idea of what that means. It means like it's like the chunk of numbers from negative infinity to negative 4, and then from 3 going up to positive infinity. So a lot of times with domain, though, our answer is all real numbers. So we know when we did parabolas, and I said, okay, what's the domain for the parabola? I said you always say all real numbers. So what if there is no endpoint? What if there's no break point in it? And it really is all real numbers. How do you express that in interval notation? Well, you do it like this. So you've got like negative infinity down at one end and positive infinity down at the other end, and your interval notation would literally be negative infinity to positive infinity, and you'd have parentheses around them both. And okay, I don't know what, that was weird. Yeah, and so you'd have parentheses around them both. And that would be the interval notation way of writing all real numbers. Now, I don't like that. Like if I have to do all real numbers, I prefer to use the funny looking R, because I think that's a lot more efficient. Now the last one is, and we'll talk about this in the next unit. We have like a whole lesson on domain, and so when I ask you guys for the domain, I guess after you've done this, you're welcome to use interval notation. But the interval here, it's like everything except the number 3. So x, or whatever your interval is, it could be anything except 3. Now, normally, I would write it like this. I actually think this is the best way to write it. I would say the set of all x such that x does not equal 3. And for most of you guys, I would accept just saying x does not equal 3, because I think that is the most obvious and simple way to say that. X doesn't equal 3. It's easier to think of what it doesn't equal. Now, if you're doing it in interval notation, it is a bit of a pain in the neck, and I think you'll prefer x does not equal 3. But what you've got there is you've got two intervals, because the 3 is breaking it up. And so you have an interval from negative infinity and then to the 3, and then again from 3 up to the positive infinity. And so it would look like this. You'd have negative infinity up to the 3, and then the other interval is 3 to infinity. Infinity always has a parenthesis. The 3 is not included. And then you have to not include the 3 again using the parenthesis and go up to the infinity. I much prefer this, because I think this is way easier than this. And it gets even worse when you have more than one break, because you have to create a separate interval for every single break that you have. So if you have 2 breaks, you need to add like a third interval, and if you have 3 breaks, you need to add a 4th interval. And so you end up, and it's so much easier to say like x doesn't equal 3 and x doesn't equal 5. Like easier. So those are some examples with a number line. So I got a couple more examples to go through. Let me click on. Okay, so these are some like other ways that you could see like interval notation come up. So number 9 is a compound inequality. We have looked at these earlier this year. So you would solve the inequality and then you might be asked to present your answer in interval notation instead of in inequality notation. So, and this is actually a great review for stuff. So remember, to solve something means to isolate the x. So whatever was done to x, we want to undo it. I can see that x is being multiplied by 2, and we're also adding a 1, and we want to undo those things. And we'll start by undoing the adding by subtracting. So I'm going to subtract 1 from the middle, but if I want to keep it like unequal, the same way that is unequal, you have to make sure you subtract 1 from everything. Otherwise, you might subtract 1 from like the wrong part, and now it's not, it's unbalanced in another way. So we have negative 4 is less than 2x is less than or equal to 4, and then we'll go ahead and divide by 2. And so we end up with negative 2 is less than x is less than or equal to 2. Now, sometimes students will benefit from like actually putting that on the number line so they can see it. And so you might want to do that. You might want to like kind of, oh, that's kind of a bad line there. Like put that on the number line. And so you've got negative 2 and you've got 2. And the negative 2 is not included, and then 2 is included, and then x is in between them. That's optional, like you don't have to do it that way. But the way this would look in interval notation is you got the negative 2, you've got the 2. The negative 2 is not included, so use a parenthesis. The 2 is included, so you would use a bracket. And that would be the interval notation way of saying it. Now, I tossed this notation out earlier. This is actually something called set builder notation. It is my personal favorite notation to use. My college algebra students know that. They know that I prefer set builder notation over interval notation. Like, interval notation really isn't my favorite. And so just so you guys know what you're looking at here, those are set symbols, okay, like right there. And then this vertical line, I did it earlier. You might have caught how I read it out loud. That is read as such that. And there are 2 other symbols that are used for such that. A colon is used for it, as well as the lowercase letters st for such that. So the way you would read that is the set of x such that x is greater than 5. The important part of that, like the really important part that like you would need to know, is this part, the x is greater than 5. So we know from our number line that if you were to look at like x is greater than 5 would be anything to the right, and it's greater than or equal to, so you would have that solid dot. And once you see it on the number line, you should be able to get the interval notation for it pretty well. You're going to start at 5. You're going to go to infinity. The 5 is included, so you use a bracket, and the infinity is not, because it's not a number. You do not have to do number lines. So if you're thinking, she's going to give us this like crazy big assignment and she's going to make us do number line, like, no. I am doing the number line to give you an extra tool in your toolbox so that you can see it and visualize it, but it's not something that I would normally do, nor is it something that I necessarily expect you to do. Last one here, and this gets into what you just took a test on. So find the domain, and you know that I was very adamant, like I wanted the inequality notation, not the interval notation. After you complete this lesson, you are free to use interval notation. But this one, and we're going to go over other ways to find domain in a future lesson, probably next Monday, but the way that we were doing it last class was this. We were looking at the transformations, and we know that goes right 3, and we know this goes up 2. So you kind of look at your coordinate plane, and it goes right 3 and up 2, and it looks something like that. And the way I was explaining it was, okay, your domain is your x's, and you're just kind of like projecting that like onto the x-axis. So it's like you're projecting it onto the horizontal number line. And now, hopefully, you'll be able to see what your interval notation would be for that. You would be starting at the 3 and going to That's the world's worst infinity. There we go. And going to infinity, including the 3, because you can plug a 3 in there. 3 minus 3 is 0, and the square root of 0 is 0. And that would be your domain, and you wouldn't need to indicate like the x. You would say the domain is, and then the interval 3 to infinity. You could do the range as well. I know that's not part of the directions, but the concept is the same. So you would come over to the y-axis, and it's just the same deal, except the number line is turned vertically. And so you're starting at the 2 and you're going up to infinity, and so your range would be 2 to infinity, including the 2. If you've got a flip or something on your graph, then you would have something that might look like this one here, where you've got like negative infinity to like negative 3 or something, or like negative infinity to negative 4. So if you've got like the flip on it and it's going the other way, you would still be able to use the interval notation for that. So those are the like 11 examples that I have. And so in order to demonstrate that you have listened to this lesson, watched the lesson, and followed along with the lesson and learned something, I'm going to have you guys do 10 problems. You can do these on a separate piece of paper and then take a picture of it and upload it into Focus. So express each of the following in interval notation. You may do a number line if the number line helps you picture it. I would have never survived graduate school without number lines. So there is no shame in doing a number line to help you picture what you're looking at. So the first one is x is greater than or equal to 4. The second one is 2 is less than x is less than 6, or you could think of it as x is between 2 and 6, not including the 2 and the 6. 3, x is less than 3. Number 4 is an inequality to solve, and so you have negative 4 is less than or equal to x plus 2 is less than 3. That'll be similar to number 9, so you can go back and take a look at number 9. Number 5, x does not equal negative 5. And to do that one, you might go check out number 8. Okay, x does not equal negative 5. Number 6, negative 7 is less than or equal to x is less than or equal to 9. Number 7, I hope I numbered that right. This is one that has an or in it, so x is less than or equal to negative 10, or x is greater than negative 7. And we did one that had an or in it. That would have been number 6. Would be one that has an or. Number 8, x is greater than or equal to negative 2. And numbers 9 and 10, find the domain of, oh, it won't let me erase the asterisk. Find the domain of y is equal to the square root of x minus 7 plus 2. And I'm not totally sure that's showing. I had to like clip what I wanted this to take a video of, and I think that bottom one got back, got like a little cut off there. But number 10, find the range of the same function, y equals the square root of x minus 7 plus 2. So you're going to find the domain and the range both of that particular function. One last thing that I want to address, and somebody probably has a question about it. If you were to see, just say this, like 1, 2, how do you know if that is the open interval from 1 to 2, which it could be? Now that you know interval notation, you know that, okay, that could be the open interval 1 to 2, not including the 1 and 2, or if it is the point 1, 2, like the actual dot, like location on the number line, the point 1, 2. And the answer is context. So it is true, those two things have the exact same notation of 1, 2 inside parentheses, and it could be the open interval from 1 to 2, or it could be the physical location of the point 1, 2, where x is 1 and y is 2. The way that you would know the difference is by the context of the problem. Usually, like if it's like domain, range, inequalities, like you're not talking about plotting an ordered pair. And if you are plotting ordered pairs, you're probably not doing something with the intervals, like an open interval. So, but if you're ever confused, it's always a question you can ask. So that wraps up this little mini lesson on interval notation. You have the problems. I would pause the video at this point so that you can take a look at them and upload them to Focus for your extra credit.